Types of sections. Now I will discuss different types of beams with respect to different conditions. Now first, types of beam section with respect to according to section stability. Depending upon the section stability, section shapes can be classified as compact, non-compact and slender section. Here I will discuss one by one what is compact section, non-compact section and slender section. Again, for these compact, non-compact and slender sections, there are criteria and specifications by AISC code. So we have to fulfill that. So that's why our section is compact, non-compact or slender section. A compact section is that one that is capable of developing or can develop its full plastic moment capacity before any local buckling. That's a good section. That section will go full plastic moment capacity before any local buckling. Okay, so in order to qualify under this category, a member must meet the following requirement here from the code reference. So first, web is continuously connected with the flange. In our I section, our web is continuously connected with the flange. First check should satisfy. Second, flange local stability criteria is satisfied. Mean flange limit will not exceed certain limit. What is limit? I will discuss in next slides. Similarly, web local buckling criteria is also satisfied. Means web will also not go for buckling. And in the compact section, the fourth condition automatically will satisfy when the flange is, I will again in the first example, I will discuss how the lateral torsion buckling is absent, and we have also discussed in the previous slides, like when our unbraced length of beam LB is less than LP, then there is lateral torsion buckling absent. So means our first criteria should also satisfy for compact section. So first of all, flange local buckling criteria. So here all is discussed should be less than or equal to LP. The parameter lambda, that is the flange local buckling criteria or slenderness ratio of this flange, for flange may be calculated as BF over 2TF. Means the total width of I section divided by 2 times, because flange is present on both sides, or BF of half flange from top divided by TF. Depending upon the whether half of the flange undergo buckling or full flange acts as a one element for buckling respectively. Here is a criteria. Our lambda should be whatsoever our flange length, our thickness ratio should be less than or equal to lambda p. And what is lambda p? Here is lambda p for compact section, unstiffened flanges. Again, I will in the types of section I will discuss what is unstiffened and stiffened. For example, let me explain here. Here is our I section. Okay, here is I section. Our web is supported on both sides. So that is a stiffened element. But our flanges are stiffened on the one side when other side is unstiffened. So that is called unstiffened flange. Unstiffened flange, unstiffened flange, unstiffened flange. So our web is stiffened. So that is the word used in this terminology. I am coming back at my same slide. Unstiffened flanges of I-shape, rolled beams, channels, T's, and built up doubly and singly symmetric I sections. Lambda p will be calculated 0.38 E over Fy, and if we use 250 megapascal for Fy grade, so our value will be 10.8 for A36 steel. So now I will for web local buckling. So height of the web divided by thickness of the web. Same way, that should also be less than lambda p. So how lambda p will be calculated? Lambda p equal to 3.76 E over Fy for A36 steel, that is 107. So I have highlighted because these values will be used in the design of beams. Now the lateral torsion buckling, the member is laterally stable when LB is less than or equal to LP, when CB is equal to 1. Okay, so non-compact section. A non-compact section is the one which can develop yielding at least one of its outer edges before showing local instability. Okay, before going to instability, but it's at least one side can go for yielding, but remember it will not go for full plastification. Okay, the width to thickness ratio of one or more element exceed LP. Okay, means our flange criteria or web criteria will exceed lambda p, but lambda for all elements do not exceed lambda r. Okay, it exceeds from lambda p but do not exceed from lambda r. The values of lambda are here in the table. Okay, unstiffened rolled flanges, unstiffened flanges for singly symmetric built up sections. Okay, and will be calculated lambda r value, and we will check that our lambda should be less than this lambda r. Now third section, that is a slender section. The type of section cannot develop yielding at any point within the cross section before it shows local instability. Mean before any yielding it will locally buckle. Okay, locally go for instability. So that type of section is called slender section. The width over thickness ratio of any element exceeds lambda r. For this type of section, our width to thickness ratio exceeds lambda r. Now the types of section with respect to supports or positions. Depending upon various aspects, the beam may be categorized as under position. There are central beams. In the plan view you have seen there are central beams, end beams, and based upon conditions, the type of beam, that is simply supported beam, cantilever beams, continuous beam, fixed ended beam, propped cantilever beams. Now the beam types with respect to fabrication, there is hot rolled steel sections that are come from the factory directly from manufacturer. Okay, we got the catalog that we have also discussed in the design of tension member, in the compression member. So hot rolled sections, steel sections here, okay, that is come from the manufacturing in the factory. Cold form sections, that are steel sheets, we pass through the compressing machine, then as per our requirement the section will be formed just like channel. Okay, so here is channel, but its flange is stiffened due to the support present at this edge. Okay, T, I section, Z section, that form from the after forming the plates that pass through the machine, then compressing you can say compressor machine, so the new section will form as per our requirement. Built up section, when the largest roll section, means the section which are manufactured in the factories that have capacities. If the lengths of the spans in the buildings exceeds 12 meter, then we have to go for built up sections like truss beams, okay, plate girder. So these types in the steel structures are used when our spans in the structures exceed 12 meter. Rolled steel sections with cover plates are used for spans up to approximately 14 meter. Mean when I section we apply extra plates at top and bottom, then we can go further 14 meter up to. But when we go above 14 meter, then definitely we have to go for build up section, steel truss, etc. And this is also modification after 12 meter. Typical build. Here is typical built up section. Here is a plate, again plate, that is connected with the angle sections. Okay, plate, web plate, and again flange plates, it connected with the welding. Okay, here is a box girder, again forming of by using built up section. Category under the built up sections. Fourth type is composite beams, means two materials are combining in this beam. When steel beams and some part of the reinforced concrete slab act together due to some type of shear connection between the two, the resulting beam is said to have a composite section. Here, the flange is embedded in the concrete slab throughout. The beam is between the two columns or connecting two beams, but the flange is entered in the concrete and casting is done in such a way that the flange is embedded in the concrete, and another way that the I section is connected with the shear keys or shear connectors that are welded on the I beam. Then when the casting is done, then the concrete rests with the connection or shear connectors with the I section. So in this way, the both sections deform simultaneously. So the both sections, concrete and steel, act or behave like a monolithic action. So in that case, this section is called composite section because the connection is fully developed between the both members. That is again the beams category. General spans that comes in the beams that are main beams that are less than or equal to 12 meter, secondary beams 4 to 6 meter, steel joists 2 to 4 meter. Here stiffeners, again types of beams depending upon stiffened beam and unstiffened beam. So here you can see stiffener plates are provided for webs, flanges, or for stability as built-up section. Here you can see vertical plate, horizontal plate that are flanges on top and bottom, and that is a web. Again, the web is stiffened with the means strengthened with this these plates, or you can say angles, so that the stiffness or the stiffness or stability will improve. So that type of beam is called stiffened beam. And if there is no vertical elements like stiffeners are not present, so that is called unstiffened beam. Okay, without any additional stiffeners. So in our I sections that are plain, okay, the webs are plain and the flanges are plain, there is no such type of vertical elements, so these all hot rolled sections are unstiffened beams.